Hello and welcome. Today we're looking at an overview of the reaction where we're looking at addition of nucleophiles to carboxylic acid derivatives. So carboxylic acid derivatives, CADs. Now if you look at this structure here, you have an alkyl group, a carbonyl group, and what I'm calling Y. Depending on what that Y is, it will determine which kind of carboxylic acid derivative. So if Y is OH, that becomes just a carboxylic acid. If Y is OR, that means alkoxy group, so something like OCH3, or different types of R, then that becomes an ester. If Y is an X, where X is group 7A compounds, which are halides or halogens, so that's bromine, chlorine, fluorine, and iodine, that becomes acid halides. So it will be acid bromide, acid chloride, acid fluoride, or acid iodide. If Y is NH2, then that becomes an amide. And it could be NH2, or it could be NHR, or NR2. It will be different types of amides. If Y is OC double bond OR, that's called a carboxylate group, then that is called acid anhydride. So for example, you have RC double bond O, and then the Y now is OC double bond OR. So that's acid anhydride. The nucleophilic reaction involves addition of the nucleophile to the carbonyl. So basically you get a substitution. The Y group is substituted by the nucleophile, and now you end up with the nucleophile occupying the same position that the Y group was occupying. And I will give another presentation on the mechanism of this reaction. There are various types of nucleophiles that can be used for this transformation. So you can use hydroxide ion, OH minus, and therefore you end up with a carboxylic acid, because instead of the nucleophile, you end up with an OH at that position. You can use alkoxide ion, that's O minus R, so something like OCH3 minus, and that will end up giving you an ester. You can use R minus, and with R minus, so R minus nucleophile, it comes from Grignard reagents, so RMGX, remember X is bromine, chlorine, fluorine, or iodine, or alkyl lithium, or dialkyl copper lithium, that's a cuprate reagent. All of those will give R minus nucleophiles. For this one here, R2, the cuprate reagent, you end up with a nucleophile in that position, so you end up with an R in that position, you end up with a ketone, so that will give ketone, and I'll show that later on. But these other two will add R minus 2 times. So the first time you get a ketone, and then the second time you end up with an alcohol, where you add those R twice. So that one and that one, and you end up with an alcohol for these two. You can also use neutral nucleophiles, and neutral nucleophiles have electron pairs. Negatively charged nucleophiles, you just use them straight. But for neutral nucleophile, you lose that hydrogen, and then you just add the Nu. So for example, water, you lose that hydrogen and you add OH. So it basically gives you the same product with the OH minus. For alcohol, you lose that hydrogen and you end up adding the OR as a nucleophile. So basically it gives you the same product with the OR minus. For amines, NH3, different types of amines, as I mentioned before, you end up adding NH2. So you lose one hydrogen. So the first one adds NH2. This one loses one hydrogen. So you end up adding NHR. This one loses one hydrogen. You end up adding NR2. Thank you very much. Please stay tuned for mechanism.